A black hole. A mysterious object in the universe that fascinates scientists and ordinary people alike. But what is it, really? Imagine taking a star many times larger than our Sun. When it runs out of fuel, it begins to collapse under its own gravity. If it's massive enough, it collapses into a point of infinite density, which we call a singularity. All matter is squeezed into an incredibly small space, and gravity becomes so strong that not even light can escape. That's why a black hole appears black. Around the singularity there is a region called the event horizon. This is the boundary of no return. Once you cross it, whether you're a spaceship, a planet, or a beam of light, there's no way back. The black hole pulls you in completely. But here's the interesting part. From an outside perspective, anything approaching the event horizon appears to slow down. To a distant observer, it looks as if the object never actually crosses the horizon. It just seems to freeze and slowly fade away. You might be wondering, if we can't look inside a black hole, how do we even know they exist? The answer is that black holes themselves are invisible, but we can observe their effects. When a black hole consumes surrounding gas or a star, the matter gets extremely hot and emits X-rays. Scientists can detect those signals with telescopes. Or they can track the movement of stars orbiting around something invisible. If those stars are moving too fast, there must be something with enormous mass there, and that something is a black hole. In our own galaxy, the Milky Way, there is a supermassive black hole at the center. It's called Sagittarius A. It has the mass of about 4 million suns, yet it's confined to a space smaller than our solar system. In 2019, scientists achieved something incredible. For the very first time, they captured an image of a black hole's outline, or more precisely, its shadow. Using a network of radio telescopes scattered all around the Earth, they created a giant virtual telescope capable of detecting light bent by the extreme gravity around the event horizon. That's how the famous picture of the black hole in the galaxy M87 was made. Another breakthrough came with the detection of gravitational waves. These are tiny ripples in the fabric of space and time, predicted by Albert Einstein more than a century ago. In 2015, the LIGO detectors finally observed them when two black holes collided. These collisions are so powerful that they shake the universe itself. Gravitational waves allow us to literally listen to cosmic events we could never see otherwise. But many questions about black holes remain. What actually happens inside? Einstein's theory of general relativity works beautifully to describe gravity, but under the extreme conditions of a singularity, it starts to break down. We need a theory that unifies gravity with quantum mechanics. That's one of the biggest challenges in modern physics. There's also Hawking radiation, the idea that black holes are not completely black. Stephen Hawking proposed that, due to quantum effects, black holes can slowly emit particles and shrink over time, eventually disappearing altogether. We've never directly observed this, but if it's true, black holes aren't eternal. So black holes open a window into the most fundamental principles of the universe. They force us to rethink time, space, and the laws of physics on an entirely new level. Perhaps one day we'll discover that they hold the answer to how the universe began, and maybe even how it will end. Whether we're talking about the supermassive giants at the centers of galaxies or the smaller ones formed from dying stars, one thing is certain. Black holes are among the most mysterious objects we know. And every new discovery brings us a little closer to understanding what lies beyond that invisible horizon.